So today we're going to start with dividing polynomials along division. So before we get started on any of the algebraic examples, I just want to refresh your memory about long division in general, because it pretty much follows a very, very similar procedure to regular long division. So you don't have to write this, just follow along. What if I said I wanted to divide 3 into 2026? What would be my first step? Yeah, so basically 3 goes into 20 6 times, and then what do?
Bring it over.
Multiply 3 times 6, which is?
18.
Then what?
Then you would subtract it.
And you get?
2.
2.
Bring down the?
2.
3 goes into 22. 7 times 3?
21.
Then what? Subtract.
Bring down 1.
Bring down.
5.
Subtract.
1.
1.
So 1 is called our what?
Remainder.
Good. And you learn to go a step further with the remainder after a while, and you put the remainder over the divisor, and you can get a fraction at the end. Do you remember that? Maybe not? Okay. That's alright. So this is just showing you how long division works. Regular polynomial long division is very similar. So I just kind of wanted to get your mind back into how that process works. But before we do that, we're going to review dividing by a monomial first. So the first thing you want to do is you want to find any possible restrictions. What number can you not divide by in math? 0. So x cannot be 0 here. Do you see why x can't be 0? That's what we call a restriction, because x cannot be 0. So we have a restriction on this. We can do this division as long as x is not 0. So now we're going to proceed with the actual problem. So what you're going to do is, since this is a monomial, you're going to write 6x to the 4th over 3x squared minus 15x to the 3rd over 3x squared plus 3x squared over 3x squared. So see how I just wrote out each of the numerator terms and divided it by that denominator?
Yes.
Now we can go ahead and simplify this. 3 goes into 6 how many times?
2.
2.
X squared goes into x to the 4th?
X squared.
X to the 2nd times. Negative 15 divided by 3 is?
Negative 5x.
X, very good, yep. And then this is just going to become?
Plus 1.
Just 1 plus 1, very good. So this is your final answer. So what do you think? Does it make sense?
Yeah.
You can toss it. You have notes from yesterday?
Yeah.
Okay. So now here we're going to do the same procedure. Now see how here I wrote it out as individual fractions? You don't have to write it out this way if you just want to do it in your head, okay? It's up to you. So here, what can't a and b be here? They can't be 0, because they would make the whole denominator 0 if so, right? So this means that this holds true except for when a is 0 and except for when b is 0. So 21 a to the 5th, b to the 3rd divided by 7ab is going to be 3 a to the 4th, b to the 2nd. Everyone see how I got that there? This divided by this is this. You all with me on that? Alright. Negative 14 divided by 7 is negative 2. A cubed divided by a is a squared. B squared divided by b is just b. And then to keep you, this divided by this is this. And then next we have 63 divided by 7 is 9. A squared divided by a is a. And the b's go away, right? So this divided by this is this. Is everyone able to follow through with that procedure? Okay. So like I said, you don't have to write it out, extra steps. That was just me trying to help you understand what we were doing in that first question. So now we're going to talk a little bit about how factoring comes into play here sometimes. When dividing a trinomial by a binomial, sometimes factoring allows us to do this. Now there is a typo on this question. This should be a negative sign instead of a plus sign, okay? Now, with that being said, is there any GCF in that numerator I can take out? No. So we're going to rely on the AC method. You remember AC method? You remember doing this? Then you factor this into two binomials. Factors of negative 30 that add up to negative 7. What about negative 10 and?
3.
Positive 3.
Positive 3.
Good. Then we divide by the A. Remember this? I don't know if you guys remember or not.
Yes.
Okay, I'm just making sure. This becomes this, and then you bring this back over in the front. You remember that? And that's all over what?
W minus 5.
Good. Now before we cancel anything out, we have to think of any possible restrictions. What couldn't W be here?
0.
Well, W could be 0 because that would result in a negative 5. What would make the denominator 0 if W was what?
5.
Just
Just 5.
5, right? Because that would be 5 minus 5, which would be 0. Now that we've done that, notice that we have identical binomials in the top and the bottom here. See that? What can I do with those?
Get rid of it.
Cancel them out, and leaves me with the final answer of?
2W plus 3.
Good, 2W plus 3. So that's dividing by factoring, okay? Dividing by factoring. So you can also divide by factoring on this one here. So as you can see, no GCF, we are going to use the AC method. What are factors of negative 8 that add up to negative 7?
1 and 7.
Good.
Oh, plus 1 and negative 7.
Negative 8.
I'm good.
It's alright. I know what you meant. So this is going to go back in the front, right? And then this is going to be H minus 2. All over what?
H minus 2.
And before we do anything, the restriction for H is what? Good. What's now going to happen here? Which leaves me with? Good. Alright. What do you all think so far? You understand it?
Yeah.
You ready to try long division now?
No.
What was it?
It's going to be okay. You're going to like it, I promise. So now we're going to go into polynomial long division. So I'm not going to read out all of these steps to you because you're not going to understand what they mean right now. So I'm going to show you how it works. And then once you learn how it works, these steps are going to act as a reference guide for you to make sure you're doing the steps accurately. So let's go ahead and try it. The first thing you want to do here is, oops, zoomed in too much. You want to make sure that your numerator and your denominator are both in standard form. Remember yesterday how we learned about standard form? So descending degree order. The degree of this term is 3. What's the degree of this term?
2.
The degree of this term?
1.
Degree of the last term?
0.
0.
Isn't it correct order?
They are in the correct order, and we're not skipping anything. See how we go 3, 2, 1, 0. If you're skipping anything, you have to put in placeholder terms, and we'll see an example like that. Now down here, this is just 1 and 0. So once again, we're in standard form. We're not skipping anything. So now we're ready to actually do the division. So you're going to make a division bar. You're going to put whatever's in the denominator on the outside, whatever's in the numerator on the inside. And I'm going to go through these steps slowly, and I'm going to try to color code them for you so you can understand. So we're going to do division kind of like we do division before. What number can I multiply x by to get me to x to the third power.
X squared.
X squared. That's what's going to go up here. And see how do you understand why I write it here? So it lines up with the other x squared term. Okay? So I figured out what I can multiply this number by that gets me to this number. So if I take x times x squared, I'm going to get x cubed. Now, once you do that, just like with regular long division, you're going to multiply whatever you have up here by your whole entire divisor. So that's going to come out to be x cubed plus 2x squared. Everyone understand how I got what's in the red? I multiplied what's in the shaded blue. Just like this. Now, with long division, you always do what? Here, you do what? You subtract. Now, when you subtract an entire binomial, you're subtracting the first term and the second term. So you have to make sure that you keep your signs in track. That's probably the most common mistake people make with this process. Now, if you did the math correctly, these first terms will always cancel out. X cubed minus x cubed cancels out, right? Now, this looks like a plus, but it's actually a minus 2x squared. What is 4x squared minus 2x squared?
2x.
Negative 6x squared, right?
Yeah.
Subtraction. If it helps you to write it out and change all the signs, you can do it that way as well. So like if you feel more comfortable flipping all the signs and erasing them, totally go ahead and do that. Now once you've gotten what you have, you're going to now bring down the next term. You remember this? Just like regular or long division. Bring down the next term. Now, what can I multiply x by to get me to negative 6x squared? Can I multiply this by negative 6x? See how they're always going to line up to, and it's just going to start going down in power. Now, you're then going to take whatever you have up here and multiply it by this whole thing. That's going to come out to be negative 6x squared minus 12x. This is in parentheses. We are subtracting it. And that was a result of the product of what's in the pink. You all with me so far? Now, remember, you're subtracting away both these terms, and they're both negative. So these are actually going to be addition, right? So if it helps you, you can change these to addition because you distributed that negative 1 out, okay? Now it's gone. Now this is taken care of, okay? So what's going to happen with these first terms? Good. What happens to these ones now? They become?
14x squared.
Just 14x. Then what do I do with the negative 3 here? Bring it down. Now, once again, factors of, basically, what would I multiply x by to get to 14x? Positive 14. Whatever you write up there, you're going to multiply this by this. That becomes 14x plus 28. Is the color coding helping you see what's happening here a little bit?
Mm-hmm.
What do I then do with this? Subtract it. And remember, you're subtracting both terms, not just one. What's going to happen with this first set?
It's going to be like eliminated.
Exactly. And this is going to be, yes, negative 3 minus 28 is negative 31. Negative 31 is our what? Remainder.
Remainder.
So if you remember how earlier we had to write our remainder over our divisor, same thing here. You have this plus your remainder over what you divided by, x plus 2. And that would be the result of the division. Now, what operation reverses division in math? Good. So, technically speaking, we're not going to do this. You could take what you divided by, multiply it by the result of your division, and obtain this. That's the whole purpose of like what we just did. Okay? Does that make sense?
Yeah.
Okay. So it's a little bit long. I don't expect you after the first one to be able to like do it on your own right now, but were you able to like track my steps and kind of understand what was happening? Not at all.
I can try.
All right. So So now we're going to try one that hopefully helps you understand it a little better, because this one's a little bit easier, okay? So the only thing about this is recognizing this looks like multiplication, but it's actually division. Because what do we have to do with something to a negative power?
Divide it.
Good, it's going to actually go down to the bottom, right, to become a positive power. Everyone see how that's equal to that?
Yes.
Negative exponent. Now we're ready to do division. That's a minus. Everyone with me on this so far? Okay, here's the procedure. What can we multiply x by to get to x squared?
X.
That goes here. Line it up with its common exponent power. Then you multiply x times this, just like regular long division. That comes out to be x squared minus
3x.
very good. This is subtracted.
The first term's
10x.
eliminated.
It is eliminated.
And it becomes 10x.
And then it becomes 10x.
Everyone understand why it becomes positive 10x? Because you're subtracting, which means the sign is always flipped. Drop the negative 30. I'm going to erase this plus 10. It just looks weird. I don't know. What can I multiply x by to get to 10x?
10.
Now what do I do? Multiply this by?
This.
10x
10x minus 30.
Good. We're going to subtract this. What's going to happen my first term?
It's going to be eliminated.
And this one
cancels out too.
That one also.
leaves me with 0, right?
Mm-hmm.
Remainder. Now if you have a remainder of 0, like you do with regular division, do you write, when you divide 6 by 24, do you write 4 remainder 0?
No.
Or do you write 4 plus 0 over 6?
No.
So you don't have to worry about that extra step when your remainder is 0. So if we did 6 goes into 24, and we get 4 as a result. 4 is a what of 24?
A multiple?
Not multiple, but a, starts with an F.
Factor.
A factor. And isn't it true that what you divided by is also a factor of 24?
Yes.
That means that this and this, x plus 3, or I'm sorry, x minus 3 and x plus 10 are both factors of this. And can't we confirm that by the fact that if I were to factor this into two binomials, what are factors of negative 30 that add up to positive 7? I kind of wrote them on the board already.
10 and negative 3.
See how if you factor this, these are the two factors of that,
Yeah.
which is the result of the division. Because what reverses division?
Multiplication.
So if you were to multiply this by this, you would get that. So does that kind of make more sense now?
Makes sense.
Okay, so that's like what you're doing. It's just sometimes they're not as nice as that one. This one just helps you understand the reasoning behind it. So this is what we call the remainder theorem. And this is actually a super important theorem that's going to come up in every math class that you take after this for the most part, unless you're going to statistics, but all the algebra-based, calc-based classes. The remainder theorem basically states that if you have a remainder of 0, that means that whatever the result of your division is and the divisor itself are both factors of the original. Alright? So very important, but it's kind of intuitive as well. Because you're already used to doing long division. You've done it many times before. Alright, so we have 2 more to try. So sometimes you're going to be asked if something is a factor of something else. And we can confirm this by doing long division, right? Because we want a remainder of 0. Now here's where you have to be extra careful. This is a 3rd degree term. This is a 1st degree term. And this is a 0 degree term. What did we skip in this one?
2.
So we have to put in what's called a placeholder term. So a placeholder term fills in whatever x that you're missing. So see how I put 0x squared in there? That doesn't change what this actually is equal to. But you know how when you do multiplication of like two-digit numbers and you have to put in the 0 when you go to do the next row?
Yeah.
You remember what I'm talking about?
Mhm.
This is the same idea as that, alright? So, now we're going to do the division. What would I multiply x by to get me to x cubed?
X squared.
I then multiply x squared by this, which gives me x,
X squared minus 1. X cubed minus 1x.
good, minus 1x squared. Subtract. What happens to the first ones?
Cancels
Cancel
out.
out.
Good. So if these do not cancel, you know you picked the wrong number up here. You know what I'm saying? So it's kind of like a way to check your math. This actually becomes
The
what?
positive, so it'd be
X
x
squared.
squared.
Very good.
And then you would multiply and bring that down.
Plus 2x.
Good. Factors of, or how do we say it? What would I multiply x by to get me to x squared?
X.
X.
I then multiply x by this right here, which comes out to be x
X
squared
Squared.
minus x, right? This is really like a 1x, same thing. So this cancels, and this becomes a plus 1x.
Positive, so it'd be 3x.
Very good. Bring down the 1. Negative 1. What would I multiply x by to get to 3x?
3.
Multiply the whole thing by 3. Subtract. Cancels?
And then that would be 2.
Very good. 2 is our what?
Remainder.
Did we get a remainder of 0?
No.
No,
So what's the answer to the question?
they're not factors.
No. Remainder was not 0. What do you think? Is it making a little more sense now?
Well,
Sure.
we probably could have told that it wasn't a factor by the point we put that we didn't find what it was like that.
That's true, but this is a 310 degree polynomial. Do you have any ideas on how to factor that? We will learn how to factor it, but it is actually tough to factor. It's not as easy as, like a quadratic. So that's kind of why we learned this process. This one here is a little more challenging. So here we have a 4th degree term, a 3rd degree term.
Second degree term. We're missing the first degree term.
Good.
Just put like a 0x there.
Exactly. And then here we're missing also
1.
the 1 degree. So we have to put in a placeholder for the divisor and the dividend. So this is going to be x squared.
Plus 0x plus 1.
Good. And the inside?
3x to the 4th minus 4x to the 3rd plus 12x to
Squared.
plus 0x plus 5.
Good. So I'm glad you're understanding the placeholders. That's good. So now we're going to proceed as we usually do. So, what would I multiply x squared by to get me to 3x to the 4th?
3x squared.
X squared.
Good. I'm then going to multiply these. That gives me 3x to the 4th plus 0x to the 3rd plus 3x squared. Subtract. Remember, you're subtracting the entire thing. Cancels.
Cancel out.
This would become,
And
Negative 4x squared.
yeah,
Cubed.
cubed. And it's because 0, you subtract it, you add it, it doesn't matter.
yeah.
Here becomes a what?
9.
9x squared.
You understand where the 9 came from?
Yeah, because the 3 is now a negative.
It is a negative. Good. Now I'm going to bring down the 0x. And now I do the same process again. What would I multiply x squared by to get to negative 4x cubed?
Negative
Negative 4x.
4x.
Good. The placeholder term also keeps us in track. It's going to, see how they always go down a power every time? So this now gets multiplied by that. You with me so far? I just multiplied
Yes.
this and this to get this. Because I haven't been highlighting it this time around. So I just double check my work every step, because if you make a mistake, it's easier to take the time to check it than to go back and try to find it. So remember, this whole thing is getting subtracted, right? So what happens to the first term?
It's eliminated.
This becomes 9x squared, and this becomes
negative 4x third. No, wait. Positive 4x.
good. What happens with the 5?
Comes
You
down.
drop the 5 down.
Last one. What would we multiply x squared by to get to 9x squared?
9.
9.
Multiply the whole thing by 9. Subtract. Cancel. 4x minus
4.
this is our what?
Remainder.
Yep. So our final answer is this plus your remainder over your divisor. Now when you write your divisor here, you don't have to put in the placeholder term, okay? So I want you to know that, because if you take a quiz in my class and it's multiple choice, I'm not going to put the placeholder in there when you have the multiple choice question, okay? So just be aware of that. I just want to make sure you understand.